Thank you so much. One more excellent presentation today by Dr. Rabie Saidi. Dr. Rabie is a lead data scientist in the European Bioinformatics Institute in Cambridge, here in the UK. He conducts research and development in the intersection of data mining, big data, machine learning, and bioinformatics. He's responsible for adapting and creating new techniques or technologies for descriptive and predictive purposes for protein data analytics. His main activities are centered on smart data-driven solutions for the annotation of proteins in UniProtKB or TREMBL. Rabie's academic background is in machine learning and data mining, and he holds a PhD in computer science from Blaise Pascal University. He will talk about getting into digital, and he will hopefully have the same amount of time and discussion venue. So, welcome, Dr. Rabie. Yeah, you can start the floor. Thank you. Now. Is it on? You can use this one as well if you want. Yeah. If it works then. If not, then.
Yeah. So, thank you for the presentation. I'm happy to be among you. And thank you, Professor Alam, for this invitation and for organizing this. Yeah, I don't need to present myself again. But today I will be talking about something a bit specific. I will be focusing on something that is more into practice and technique, and all about data and around data. So getting into digital. When we say getting into digital, actually, we have three main terms that are being talked about. Digitalization, and transformation and digital transformation. Basically, they are interchangeably used in articles, papers, and so on. But recently, many people tend to distinguish between them. All right? And to make each of them related to some specific field of concepts. Digitization is simply making data into digital format, just to make it machine readable, to make the machine able to read it. So it's about data. Digitalization is about the process that would be applied on data. So to get the most of it, I mean, using machine learning, simple automation, whatever, that gets the use of data further than the manual and classical use. And finally, the digital transformation is when you can make all your business using digitized data and digitalized processes. All right? Where I work, for example, we took what is called protein curation or biological curation from the manual process of biologists trying to understand the data and then annotate them with functions, with biological information. We took it from there into a whole automated process where we created data and then other automated processes, including artificial intelligence, data transformation, and so on, and we put that into a digital shape. Website, databases, services, automatic pipelines, all of this. I mean, when I say business here, it could be research, academia, or even private sector. I mean, the business in terms of job. All right. So it's not only something, I mean, getting into digital is not something that is a concern for business or academia only, but for governments as well. And recently we can see that governments are interested into this in two ways. The first way is to plan for strategies, like to have a vision. Some of them are just blah blah, just for the hype and for political reasons, but some of them are really serious. Since I'm African, so I'm interested in more interested in speaking about African countries, and we can see that in early 20. Oh wow! So how to get? What's the pointer here? Is there any pointer?
Yeah, it didn't work.
I don't know. No point. So I keep talking. No, I just need the pointer to point. It's not okay. No problem. No problem. So, Kenya started something in early 2018, and then Tunisia in April 2018. So this sometimes come with mega projects like Station F in Paris for France. And Tunisia copied something, is not very mega, that is called Station T or Station T, where they gather startups into a huge, unique space. Thanks. Just to facilitate for them all the processes and funding, technological help, etc., to help them flourish. Okay, this is, I mean, some sort of political decision that is into mechanisms, methods, infrastructure, but also about data. I presume some of you or a few of you know about the Open Government Partnership, the OGP program, which is meant to provide a platform for governments and rulers or even civil society to provide data that make things or governors more accountable, and to help as well catching needs of citizens. So here we have data, okay? Strategies about AI stuff, and for the previous one, you can check Politics plus AI website. You can see the interest of governments into this trend. And then as well, data, and as you can see, maybe Africa is not very covered. I mean, a few countries have developed action plans. Some of them started implementing these action plans, like to get into digital and to provide data that is open, etc., etc. While America is very well covered, and Europe, well, the usual stuff that you know. But of course, there is some specificity in Asia because, for example, Russia and China are not expected to join this kind of programs, because they want to build, especially China, they want to build their own technosphere. All right, talking about data, maybe we need to understand a little bit about data, because I think that the etymology is a bit important here. I suppose maybe for native speakers, I mean English native speakers, they don't really know the etymology behind data. While, for example, I suppose people who are from who have Latin language background, I mean across Europe, they understand this differently, because simply data is the plural of datum in Latin, okay? And datum is simply something that is given. You don't make any effort to get it. It comes to you. For example, in Spanish, to give is dar. In Latin, dare. Datum is the participle of dare in Latin, all right? So this is something given to you. You don't make any effort to get it, and maybe it doesn't even have a context. You catch it, but maybe it doesn't have a meaning. When it gets a meaning and it gets into a context, it becomes an information, or it becomes information, which is simply news. You understand what that is. Let's say A exists. A datum could be anything you spot. As soon as you understand what is going on, that's information. All right? A exists. A is datum. A exists. That is information. And then there is a transcendental process from data to information to something even more specific than information, which is knowledge. That you can understand it as a model to explain something, a rule. If A exists, then B as well. This is a rule. Okay? And as you can see here, knowledge swim in a sea of information, same for information with data. Plenty of data. Sometimes we don't make any sense of them. They exist. We try to get information, and from information we try to get knowledge. And when we get knowledge, we can get even more information. All right? But there is even another level of data, which is wisdom, but this gets into philosophy, and we don't need to get into that. So why data is so important, or are so important? Because that's plural. Because they have to drive our decision. If we disagree, we need something objective. We are not objective. There are several factors or engines or motors that drive our decisions. This is, for example, a fictitious mechanism that drives decisions and is a balanced set of intuition, customers, finance, data, technologies. There might be more factors than this, but this is a fictitious balanced mechanism of taking decision. Intuition is a very strong factor, and this could lead to democracy when if people are consulted here, or dictatorship if the guy thinks he's the best to know and he has the ultimate knowledge. Intuition is dangerous. And there is the data-driven way, which gives a huge weight to data, where decision relies on data. And I like this quote from James Barksdale, who says, if we have data, let's look at the data. If all we have are opinions, let's go with mine. It's a nice way to say things. Is a sort of smart dictatorship. It sounds. But then, the thing is, getting digital or getting into digital means being data-driven. Because it starts with digitizing your data, digitalizing your processes, putting the whole into a digital business package. But then, so decisions should be based on data. But not only that, decisions that are based on data should as well produce data. So we have data, you get some sort of insights, and when we say insights here, remember knowledge, rules that could explain things. So, and then you do your decision and you make your actions. These actions should produce new data for two reasons. To assess what you've done, to correct what you've done, but also to enrich and to understand more to get new insights. And this very nice loop is very fruitful. Because, of course, you can decide based on data and you make mistakes. But at least, because you have the log of that, because you generated data of that, you can correct yourself. And learning comes always with mistakes. How to do this? I mean, how to get this lump, the insights, the knowledge, the things that enable us to understand things. Data science, okay? I suppose some of you or many of you heard of this concept, which is not new, by the way, is all what is needed as skills to deal with data in a scientific way. And as you can see, it's the intersection between three fields that I like to call three languages: math and statistics, which is the language of the universe, the language of the machine, computer science and IT, and then the language of the business, like biology, journalism, finance, banking, whatever. All right? As soon as you have this, I mean, unified in a person or a team, so you can speak about data science. And of course, you can see here these binary intersections between the different fields, like machine learning which requires a good understanding of maths and computer science, because machine learning is algebra, algorithmic, etc., etc. And then you need to put that into programs that really works. Software development, the traditional research, which suppose that the researcher have some understanding of statistics and the domain of expertise. So this is data science, which was coined, maybe is not new, since 2012 in some report that gives a good definition for that, very similar to this one. What does this kind of science give us? Two main things. Two main knowledge, and these two types of knowledge enable a third one. Going through two main processes. So, in data science, people learn how to transform data, how to make it in a good shape for whatever we want, in an efficient way, combining big data technologies, but also techniques and algorithms from machine learning and artificial intelligence. And then discovering the pieces that are called knowledge, insights. Two main processes. All right. And then you can have, out of that, two types of knowledge, like the descriptive one and the predictive one. I would say that the descriptive knowledge is something that is hidden in the space. Let's say, for example, here, a descriptive knowledge would be the distribution of nationalities existing in here. We see people, okay, but we don't see this knowledge. It's hidden in the space. Or the distribution of male and female in this room. We see there are men and women, but is the knowledge about that is hidden. Or predictive, which is something hidden in time, either in the past or the future. Let's say where the GDP is going in the next year, or if there will be an increase in something or a decrease, predictive things, or was it like that in the past or not? We can predict this kind of thing. For what? To give some sort of prescriptions. Prescriptive knowledge, which is what should you do to prevent something, or to improve something, or to emphasize something. All right? In the two processes, knowledge discovery in purple, and data transformation in burgundy or red burgundy. The hardest task is data transformation. It takes from 50 to 80% of the total time of data processing. Okay? When dealing with real data, so it's a very hard process. In this case, because that depends always on the fuel, which is data. If the data is in a good shape, this will be easier than expected. If not, most of the time will be spent here, and this will wait for this. The knowledge discovery will wait for the data transformation. We will be waiting for knowledge. We will be waiting for actions, etc., etc. That's why data should take or should respect a set of principles that are summed into a concept, one concept, which is called FAIR. The FAIR principle that should data respect to facilitate the knowledge discovery and data transformation. And FAIR is an acronym of findable, accessible, interoperable, reusable. And this, I mean, the main paper that was talking about this is a paper of Mark Wilkinson, and it was in 2016. And he was explaining these principles, which I will explain soon. I usually don't like this kind of qualitative adjectives in science, like fair, deep learning, and smart stuff. But when science is mixed with business, we don't have a choice. I mean, we should use their terms. I will go one by one and quickly on these different terms because I have 4 minutes.
Yeah, okay.
All right, don't worry. No worries. I mean, the term comes from the scientific communities. And this survey was done last year in 2018, asking some people from different disciplines if they know about it, if they have used or never used it before. As you can see, the gray color here is the most predominant here. I mean, most of people never heard about it. A few of them heard about it, and even fewer used it. This is in the scientific community. But there is something that we should know. Maybe you said, okay, is fair data open data? No, is not. The best is when fair data becomes open. For open data, actually, I know that there are some principles or criteria that data should respect to be considered open. But the term itself, the meaning of the term itself, doesn't imply this, because open simply means no restrictions. Is there, the data is there. But people keep telling that open data should be in a standard format, etc., etc. But okay, you can add, in that case, you can add whatever you want of criteria. But anyway, so fair and open data should not be conflated, because fair data could be restricted in your team. It's just for you, okay, in your institution, etc., in your country. But it should respect the 4 principles: findable, accessible, interoperable, reusable, which I will explain right now. And then the best is when data is at the same time fair, but also open. Okay, fairness. Fairness of data. I'll be fair. I'll be fair, yeah. I'm sorry. Okay. The first principle, I mean, it's all about the reusability, to make using the data the use of the data easy and the reuse even easier. We have 3 principles that serve the 4th one. Findable means each instance of data should have an ID, a permanent and persistent one. This is the minimum requirement. Accessible, I can access this via standard communication, like via internet. And then interoperable, it has a standard format. Okay? If you make a good description, if you have these 3, then your data could be used here and reused elsewhere. If you make more description, it could be reused even more widely. To evaluate your data, there are some processes, like here to evaluate it, how fair it is. For example, if you have like a persistent ID for each of your instances, and then you have enough metadata to describe it, then you can give it some sort of rate. If you judge that your data is not fair enough, you can go through this 7-step verification process, which I've done in the European Bioinformatics Institute, but also in other stuff related to sustainable development. And then, as soon as you do that, these fair data can make you detect other unfair, non-fair data and verify it again. And this will enable you, and I finish with this, to get good fuel, good data, which could be summarized into this nice and fair object model, data object, I mean, which here you have your data. You need to make sure that your data should have this green layer of identifiers, persistent. It doesn't change like every year no, it's persistent. And then the red layer is make sure your data is using standard format, XML, JSON, whatever. And then make sure everything in your data, and this is the metadata, everything is described. Simply to make the life of programmers easier. If they see the data, they can understand everything. They make programs faster. They can generate knowledge faster. Thank you very much.
Thank you so much, Dr. Rabie. We'll have time for 2 questions, please. Dr. Rabie will stay with us in the break, so if you have any more questions, you can ask him. So any quick question, please? Yeah, go ahead, please.
Considering that the FAIR model says the data has to be accessible, considering that the FAIR model says the data needs to be accessible, how do you ensure that the data is accessible whilst also being secure? Because some data is obviously sensitive and needs to be kept like secure. Thank you.
How to ensure the balance between accessibility and sensitivity of data, right? Well, I mean, you can always make restrictions. The thing is that when we say fair data is not like open, not necessarily open to everyone. But remember that any access has a trace. Any action when you get into digital, any action done should generate data. If the data are there and then I access, there must be some trace that I've accessed it. All right? For accountability. This is the digital and the data-driven process, all of it. Any action should have a trace. Of course, things could happen, all right? But at least accountability is guaranteed. Thanks.
Thank you. One more question, please. Yeah.
Is this working? Yep. Thank you for that presentation. You touched on it around the digital transformation, about focusing on the needs of community and society. And but it seemed to get lost somewhere in your process in terms of how the accountability and the and the feedback from society in terms of meeting its needs, this process. Could you explain a bit more detail how that fits into the overall model? Oh, sorry.
Okay. But just to clarify something, I mean, we'll interact now. But do you mean in sustainable development specifically, or in any kind of business?
Specifically around sustainable development, given that this is a topic, and we're thinking of local people, local communities, and somehow they ought to be at the heart, especially when it comes to digital transformation. So you seem to touch on it at the beginning, but then I seem to get lost. Okay, so but where is the public voice within the process? And this evidence and this data that's being gathered. Yeah.
Can I? Okay. So for this I can give, because actually I was limited to 15 slides and 15 minutes. Well, I wasn't fair about this. But there are so many examples that involve public into processes like this. I can give you one that is done by Yelp. I don't know if you know Yelp, the site that where people make reviews. YELP. They make reviews about restaurant. So here people are strictly involved. What is happening is that all these reviews are processed, okay, to detect restaurants that should be checked for violating hygiene rules and stuff. And this has increased like the accuracy of detecting such restaurant by 25%. People are strongly involved in this kind of stuff, and they know. I can give you even more. This website recently gives hygiene score based on the data, and people could see this. You see, there are so many other examples actually involved in this kind of stuff, like tracing. I mean, where people actually, when you see a product, I mean, this is for maybe for ethical consumers. There are some applications that these people, these consumers, are involved in spotting any kind of unfair trading for such product from land to shelves.
Thank you so much for the answer. We can't, unfortunately, take more questions, but Dr. Rabie will stay with us. So if you have any questions, you can take this discussion. I'd like to thank you, the three presenters, for the stimulating discussion and the very good presentation.
So please remember, if we all help and do a little bit, it will make a big difference.